Ayushi, can you hear me? I can't hear you, Ayushi. Ayushi, can you hear me now?
Sorry, sir.
Okay, no problem. So now you can hear me. Okay. So today, China is not going to join because she has exam tomorrow.
Okay, sir.
So we'll start with equation of trajectory in projectile motion. So first, let's understand what is trajectory. So what exactly is the meaning of trajectory? Trajectory means it's a kind of mathematical relationship between the x and y coordinate of any point. Suppose if we pick any point, then it will have x and y coordinate. So there must be some certain relationship between x coordinate and y coordinate. So that relation is known as equation of trajectory, right? So let's assume that like no one particle is projected at initial speed u at some angle theta. So it will follow parabolic path. So at any moment you can write displacement along x-axis and displacement along y-axis. Suppose this is the point that I want to talk about. So for this point, this will be x displacement along x-axis, and this will be displacement along y-axis, vertical, right? So I have to write this x and y. How would you write? Suppose this is positive side and this is positive side. Displacement along x-axis would be ux, initial velocity along x-axis, into time plus half into acceleration along x-axis into t square. We know that this ux would be u cos theta into time plus half. There is no acceleration along x-axis, so this is 0, 0. So x would be u cos theta into t. First relation. Second relation for y. This is uy into t plus half ay into t square. Initial component of the velocity will be u sin theta into t minus half g t square. So we have two equations here. Whenever we find the equation of trajectory, we can see that we have theta, we have u, and x and y we have to keep. But we can see one extra parameter, that is time, t. So we have to eliminate that extra parameter. So you have to eliminate that. Eliminate.
Done, sir.
Okay, so now we have two equations. We have to eliminate time from here. So from equation 1, you can see that time can be written as x upon u cos theta, and put this time in equation 2. So y will be u cos theta into x by u cos theta. Sorry, u sin theta. This is u sin theta. This is u sin theta minus half g into x upon u cos theta whole square. So u gone. This is x tan theta minus g x square upon 2 u square cos square theta. This is the equation of trajectory that you have to remember. Note it down. So equation of trajectory is y equal to x tan theta minus g x square upon 2 u square cos square theta. Note it down.
Done, sir.
Now see. So now we'll remember this formula: x tan theta minus g x square upon 2 u square cos square theta. This is the equation of trajectory. You can also redefine it. How? Take x tan theta common. Take x tan theta common. 1 minus g x square upon x tan theta into 2 u square cos square theta. X tan theta 1 minus x gone gx upon tan theta is sine upon cos. 1 cos gone x tan theta 1 minus gx upon, you can see here, this is u square 2 sine theta into cos theta, that is sine 2 theta. You know the formula of range. What is this? U square sine 2 theta upon g. So this can simply be replaced by range r, x upon r. So this is also an important formula. Y equal to, you can also define equation of trajectory in this form. Y equal to x tan theta 1 minus x upon r.
Done, sir.
Done? Okay. Now let's take one simple example. Suppose from ground, we project a ball, suppose, with some initial velocity like 20 meter per second at some angle theta. There is, this is the, suppose this is the target or some fruit hanging from a tree. You have to hit this fruit. The distance from this point where you project the particle to the tree is, let's say, 20 meter, and height of this fruit is from ground 10 meter, right? And here is your ball, and this is your supposed target. You have to hit this target. So you have to find angle theta, find theta, so that ball will hit the target. Now see, suppose, now you can think, if a ball will go this path, if this is your target, so point where you throw the ball, you can assume it origin, and the coordinate of this target would be 20, 10, 20 along x-axis and 10 along y-axis. And if this ball goes this path, then definitely it will not hit. This path, definitely it will not hit. This path, definitely it will not hit. So to hit this target, ball has to follow this path. It means that this should be the required parabolic path. It means that this point must lie on the trajectory of the ball, right? So what we will do is, we'll write the equation of trajectory, and this point must satisfy that equation. So first you write the equation of trajectory. So that is equation of trajectory. Y equal to x tan theta minus gx square upon 2 u square cos square theta. And this point must satisfy. Put here 20 tan theta minus g is 10, x is 20. That is 400 upon 2 into u square is 400 into 1 upon cos square theta. That is sec square theta. So sec square theta can be written as 1 plus tan square theta. This gone. This gone. Now you can solve it. Tan equal to 20 tan theta minus 5 minus 5 or wait 1 plus tan square theta 5 4 2. So tan square theta minus 4 tan theta and plus 3 equal to 0. We have got quadratic in tan theta. We will calculate the root. Minus b plus minus under root b squared minus 4a c upon 2a. So this is 4 plus minus under root 4, that is 2 by 2. That is 3 second or 1 second. So we have got two results. No, we have to find theta, no?
Yes, sir.
Tan theta equal to 1 and 3, na?
So, how did we get the second step?
Which second step?
1 plus tan square theta.
So 1 upon cos square theta will give you sec square theta, na? 1 upon cos square theta is sec square theta, na? And for sec square theta, you can apply the identity sec square theta minus tan square theta equal to 1. So, and if tan theta is 1, so theta is 45
Oh,
degree,
okay.
and tan theta is 3, then theta is tan inverse 3. So at this angle, if you throw the ball, it will hit the target.
So, if we don't know the value of the angle when tan theta is 3, we can just say tan inverse of
Tan inverse 3, because 3 is not the standard angle.
so done.
Done. Paras, you also done?
Yes, sir.
Let's take one more example. Example number 2. Suppose you project a You throw a ball from here with some velocity, suppose initial speed u and some angle theta. And this ball will just graze the wall. Suppose there is a wall standing over here. This is the wall. That is 4 meters from the point where you throw the ball, and height of the ball is also 4 meters. This ball will just graze the wall. It means that it will just touch the top of the wall, and it will follow the path and fall on the ground. And this ball falls 14 meters ahead of the wall, right? So projected ball is grazing the wall and falls on the ground 14 meters ahead of the wall. Find initial speed of projection, initial speed of projection and angle of projection. Solve it. I'll be back in a few seconds. Done or not? It's very simple, na? It is the question says that the ball will just graze the wall. It means that it will just touch the top of the wall. So it will pass through this point. It is like this top of the wall must lie on the trajectory of the ball, isn't it? So assume this is your origin, and the coordinate of this point would be 4 along x-axis, 4 along y-axis. So 4 comma 4. Assume this is x-axis and this is y-axis. So write the equation of trajectory. What is that? Y equal to, you can simply use this thing, x tan theta 1 minus x upon r. I have used this formula because I know that the range of the motion, the range is 4 plus 14, that is 18. I have range with us. So put this 4 equal to 4 into tan theta 1 minus x. X means what? 4 and range is 18. So 2 upon 9. So 4 gone. 1 equal to tan theta into 7 upon 9. So here is the angle 9 upon 7. So theta is tan inverse 9 by 7. Also r equal to u square sine 2 theta upon g. You can easily find u. That is u is under root sine 2 theta upon gr. You have tan theta 9 by 7. You can use this formula. Sine 2 theta is 2 tan theta upon 1 plus tan square theta. Put here 2 into 9 by 7 upon 1 plus 81 by 49. Put this value here and you will get the answer of u.
Sir, here we first used equation of trajectory of that range form. Then can we again use the first form and substitute cos square theta as 1 upon sec square theta, and then theta into tan. From there we can find u.
You can do that.
Okay.
That might be a little long.
Yes, sir.
My solution would be shorter. There may be n number of ways to solve one problem, but whatever I'll give you, that will be the best.
Yes.
Sir, u should be root over gr by sine 2 theta, right?
Oh, acha, yeah, you are right. It would be under root gr by sine 2 theta. My bad.
Sir, could you please scroll down a little?
Hmm. There is nothing downward.
Yes. Done, sir.
Try this one.
So is range a cube minus b cube upon a square minus b square? So
No. Let me solve. See, it is saying that a particle projected from origin at some angle to the horizontal passing through these 2 points. So, suppose from here, this is positive x-axis, this is positive y-axis. A particle is projected with some speed at some angle theta. It will follow this path. Suppose it will pass through 2 points A comma B and B comma A. Refer to horizontal and vertical axis through points of projection. Okay. Find horizontal range and angle of projection. You have to find this R and theta. You have to find, right? So first you have to write, because you have to find range. So you need to use this formula. Y equal to x tan theta 1 minus x upon R. Now both the points must satisfy this equation. Satisfy this. So this would be B equal to A tan theta 1 minus A upon R, first equation, and this point will also satisfy. So A equal to B tan theta 1 minus B upon R. You just have to solve these two equations and you will get R. Theta is not given. Theta is not given. Just divide equation 1 upon equation 2. Just divide it. So this will be B by A equal to A by B, tan theta cancel, and 1 minus A by, or you can do one thing, you can take LCM as well. So this is R minus A upon R minus B, and 1R will cancel. So this will come this side. This will be B square upon A square equal to R minus A upon R minus B. Cross multiply R minus B into B square equal to R minus A into A square. So this is RB square minus BQ equal to RA square minus AQ. So bring this to right side and this to left side. So it is AQ minus BQ equal to R will be taken out. So R we can have AQ minus BQ upon A square minus B square. This is your range. Understood? And now if you put this R in any of the equation 1 or equation 2, you will get tan theta as well. That is what you want to, no. Yeah, that is what you wanted to calculate. We already got range and you have to find angle of projection. So from here you can get theta. You just have to put this R here in any of the equation, you will get theta. Understood now?
Yes.
Note it down.
Sir, so theta will be tan inverse of a cube minus b cube by a square b minus ab square.
You can simply put and find. That is nothing like no. You just have to put this value in any
Sir,
of the equation and you will get the answer.
yes, sir. That's I did that only.
Okay. Let's move ahead. Let's do one more thing. One more question. Question is. Uh, Question is a particle is projected over a triangular structure from one of its corner. A particle is projected over a triangular structure from one of its corner of its horizontal base. Grazing over its top vertex. It falls on other corner of horizontal base. If alpha and beta are base angles of triangular structure and theta is the angle of projection, so that tan theta equal to tan alpha plus tan beta. Just think about this, how to solve this. Okay, so did you go through the complete thing? Like, did you at least read the question?
Sir, 2 minutes. Just 2.
Okay, okay, fine. Solve, try. No, I see. That is not the correct way. I'll explain you. Wait.
Okay, sir.
Suppose this is the triangular structure. And this is the horizontal base. Question says that a ball is projected over a triangular structure from one of its corner of its horizontal base. Suppose you just project the ball from this end. You project the ball from this end at some angle, let's say theta, with some speed u. It is saying that this ball will go and it will just graze the top, means just touch, graze the top and will fall to the other corner of the base. It means that this length would be its range, right? Just drop a perpendicular from here to here or to the base. And see, assume this is the origin, assume it, this is origin, and this length is A, and this length is B, and height of the triangle is H. This angle is alpha, and this angle is beta. So, this is the origin. So, you can see that the coordinate of this point is, top point is A comma H. So, this A comma H must lie on the trajectory of the ball. So, trajectory of the ball would be X tan theta 1 minus X upon R, and range is how much? The range is A plus B put here. This point must satisfy this. So H equal to A tan theta 1 minus A upon A plus B. And we are almost done actually. Tan theta is how much? H by A. And this will go to this side. And it will be like LCM B. Now you can see tan theta is, you can divide this by, this is A into B. Na? So H, A upon AB, 1 by B, B upon AB, 1 by A. So this is H upon A plus H upon B. In this triangle, you can see that tan alpha is perpendicular upon base. And in other triangle, you can see that tan beta is perpendicular upon base. So you can write this as tan alpha plus tan beta. Proof. Understood?
Yes, sir.
Paras, you understood?
Yes, sir.
Noted down.
Done, sir.
Done, sir.
Now there is one term, radius of curvature. Radius of curvature and center of curvature as well. Suppose any ball like follow this kind of path, this kind of path. Any particle follows this kind of path. So radius of curvature and center of curvature is like, see, this for this part, if we see for this part, so this is like it's a part of circle. It's a part of circle. This circle. So the center of this circle is called center of curvature, and the radius of this circle is known as radius of curvature. And for this part, you can see this curved part can be a part of a different circle. So this is the center of curvature of this curved shaped path, and this is the radius of curvature. And for this, you can see this can be the circle. So this curved path is a part of the this circle. So this will be the center of curvature, and R3 will be radius of curvature. So suppose if you get any standard equation like if I take suppose an example of suppose a particle follows a path, and uh, as per the certain rule, like the x coordinate of the particle will vary something like a cos omega t, and y coordinate of the particle will vary like a sine omega t, something like that, right? So you can see that omega and t are variables. So what you have to do is you have to eliminate this. So how do you eliminate? From this equation, cos of omega t can be written as x by a, and from this equation, sine omega t can be written as y by a. Just square it and add it. So you will get sine square omega t plus cos square omega t equal to x square by a square plus y square by a square. And this is 1. So we have this equation. And this is the equation of circle. This is the equation of circle. center at origin, 0, 0, and radius is a. So see, this is the standard equation. So we can easily find its center of curvature and radius of curvature, that is a. But if you get some equation that is not a standard, then how would you find the radius of curvature, right? So there is a formula for that. And that formula is radius of curvature is 1 plus dy by dx whole square to the power 3 by 2 upon d2y by dx square. This you have to remember. I'll show you an example. Note it down first. I'll show you an example.
Sir, after x square plus y square is equal to a square, I didn't understand radius of curvature formula.
This is the equation of circle whose center is at 0, 0 and radius is a. And radius of the circle is known as radius of the curvature because the curve is circle only. Right? Or not right? Understood now?
Sir, I didn't understand the formula, radius of curvature.
No, you don't have to understand. You just have to remember this. I'll make you understand. Wait, now I'll take one example.
Okay, sir.
So thus you have to remember the radius of curvature is 1 plus dy by dx whole square to the power 3 by 2 upon d2y by dx square. You don't need to go into the derivation part of this. See, the question is this. Question says that you have to find the curvature of a trajectory. A particle moves in the xy plane coordinate system with velocity vector given as this. So velocity vector is ai plus bxj. So from here you can see that you can find the x component of the velocity, that is a, and y component of the velocity, that is dx. At t equal to 0, it starts from 0, 0. At t equal to 0, it starts from origin 0, 0. So you have to find the radius of curvature of the particle's trajectory as a function of x. You know the radius of curvature, 1 plus dy by dx whole square to the power 3 by 2 upon d2y by dx square. So first you find the equation of trajectory. Means you have to eliminate the extra parameter if there is any. So dx by vx is what? Dx by dt, okay, vy, that is dy by dt. From here you can see dx is a into dt. Integration, if you take a is constant, it will come out from 0 to x, from 0 to time, because it has started a motion at t equal to 0. So this is x equal to a into t. Now from here you can see dy equal to bx dt. Now you cannot integrate this, because you have to integrate with respect to t, but the variable is x. So this variable must be in terms of t. So this x you have to replace here. So dy equal to b into at into dt. Now we have to integrate this dy. A into b is constant, it will come out, and t into dt will be here. From 0 to at t equal to 0, position was 0, t equal to time, y displacement will have some value. So this is y, and ab t square by 2. Now with the help of these two equations, you have to replace the time. How do you replace? So y equal to ab upon 2, you can put t equal to x by a over here. X squared by a squared. A gone. So the equation of trajectory is b upon 2a into x squared. This is the equation of trajectory. On this path, the particle will move, right? Now you have to find dy by dx. So first you find dy by dx. So differentiate y with respect to x. So b by 2a is constant, and x squared, differentiation of x squared will be 2x, because if you differentiate x raised to n, so power will come down, or x will have 1 less power. So x squared, 2 will come down, and it will have 2 minus 1. So 2 gone, we have b by a into x. Again, you have to differentiate d2y by dx squared. It means that second time you have to differentiate. First time, this is first time differentiation, and this is second time differentiation. So again, b by a is constant, it will come out, and differentiation of x with respect to x is 1. Now I'll put these two information here. So the radius of curvature is 1 plus dy by dx whole square. Dy by dx is what? B by a into x whole square to the power 3 by 2 upon d2y by dx square. That is b by a. This is your answer, radius of curvature. Understood or not?
Yes, sir.
You have to remember the formula, but you have to learn the way how we use it. Note it down. Paras, you understood or
So,
not?
yes, sir. So what if d square y upon dx square becomes 0?
Hey, why are you talking
Then it
about
will,
this? It is becoming 0. This is not calculus.
no, sir, in any situation, if first derivative is constant,
Oh, that is different concept actually.
okay,
That will talk in math.
okay, sir. So
Done.
So here we know dx by dt and dy by dt, and we want dy by dx. And can we divide that both from here only? Then directly we will get dy by dx.
You can do. You can do.
Okay, sir.
Noted. Ayushi.
No, no, sir. Could you please scroll down once? Done, sir.
So you're on mute.
Oh, this is the diagram. I'm drawing the diagram first. So these are the two walls. This is the point from where a man is projecting a ball at some angle, let's say 15 degree. This ball will go and strike the wall elastically. I'll write in word as well. This ball will go and strike the wall B elastically. And this distance is 4 meter and this is 6 meter. Right. Now, let me write. Let me now write in the in word. Figure shows a boy throwing a ball towards uh, wall B, towards wall B at a speed 20 meter per second at theta equal to 45 degree. Sorry, 15 degree. Theta is 15 degree. If all collisions of ball with the walls are considered to be elastic. Find where exactly the ball will finally land on the ground. Figure shows a boy throwing a ball towards wall B at speed 20 meter per second at theta equal to 15 degree. If all collisions of ball with walls are considered to be elastic, then you have to find where exactly the ball will finally land on the ground. Elastic collision means the speed with which it will strike the wall, it will rebound back by the same speed and at the same angle at which it it will strike the wall at the same angle, it will rebound back as well. So this is the meaning of elastic collision. Now the strike. Think for 2 minutes. I know that you won't be able to solve this, but at least think. Try to think. Okay, let me tell
Sir,
you.
we need to calculate the range and then
Yes, correct, correct. First thing
subtract.
you must, yes. First thing you must calculate the range. So first you find the range. R is u square sine 2 theta upon g. U initial velocity is given, that is 20 meter per second to 400, and angle is 15 degree. So angle it will be sine 30 degree upon g is 10. So this is half will come down. So the range is 20 meter. Range is 20 meter. And all collisions are elastic collisions. So now you think if this wall was not here, so this ball must have gone through all the way and fall on the earth, fall on the ground somewhere here, like this. If this wall was not here, this would have gone this way and fall on the ground like this. So this complete thing is what? Range, and that is 20 meter. So this is 6 meter. So this will be 14 meter, Balak. Now this this collision is completely elastic. So elastic collision, you know what is this? So it will rebound with the same speed after striking the wall. Suppose it is striking the wall at some certain angle like this. This is the horizontal. So it is making some angle with horizontal. Suppose this angle is theta. So obviously elastic collision says that if it is striking at some angle with horizontal, it will rebound at the same angle with the horizontal. This is the meaning of elastic collision. So it will rebound at the same angle at which it will strike the ground, and with the same velocity as well, same speed as well. Understood? Now you can think here that And it is like, if everything is same, then it is like whatever path it will follow now, that will be completely mirror image of this path. So it will follow after striking this, it will follow certain path. So that path will be completely mirror image of this path. Did you understand this part? Because this is completely elastic collision. There is no friction over here, nothing. So it will not lose any energy. So if this wall was not here, then this ball would have gone this way and fall here on the ground. Because of the wall, it will rebound and it will follow the exactly same mirror image, mirror path of this. So if it is like this, so this ball will definitely come over here and will strike somewhere like this, because this part is how much? 14 meter. This part is 14 meter and this part is 6 plus 4, 10 meter. So if this wall was not here, this would have gone like this and fall over here somewhere here, because this is 14 and this after striking, this will follow the complete mirror image path. So this will also be 14. So this is 4, this is 6. So this is another 4 meter from here. But the wall is here. Now again it will strike here. Suppose it strikes at some certain angle with horizontal or vertical. Suppose alpha. So after it will rebound at the same angle with the same speed. Suppose this is V dash. So it will rebound with the same speed and at same angle with the horizontal. And I told you that if this is elastic collision, it will follow this same, like exactly mirror image path. So if the wall was not here, it would have gone this way, but wall is here. So the mirror image of this path is something like this, because this is 4 meter and this is also 4 meter. And these two paths must be mirror image of each other. So actually this ball will land at the point from where Y was projecting the ball. Understood?
Yes, sir.
So finally, the ball will land on the ground at the same point where Y projected the ball. Paras, did you understand the concept? This was very good concept.
Yes, sir. Sir,
Okay,
but
I'll ask
when
you.
the when the ball rebounded at it may at an angle alpha, there it is not mentioned that it is an elastic collision. We have to consider that.
No, all collisions. It has said that question
Okay.
has already said that all collisions will be considered as elastic collision.
Yes. Okay. Okay, sir.
Done, sir.
So if you guys have understood this concept, let me ask you one more question on similar concept giving you. Try this. Try this. Are you guys getting like how to do this?
Sir, we'll find range again, but how will we find range if angle is
Let me tell you. Let me tell you. See, it is saying that a small ball is moving with the speed of 6 meters per second on horizontal surface, falls in a vertical trench 4 meters wide and 20 meters deep. Okay. Consider all collisions elastic and friction is absent everywhere. Elastic means again same thing. It will rebound with same speed and same angle, right? So analyze the complete motion of the ball until it comes out of the trench and the point where it comes out. See, when this will fall down, it will fall down. So this is coming like this. So when this will fall down, it will come like this. Come like this. If the wall was not here, it would have gone this far. right? So now you can see how much time it will take to come down. How much time? You can apply displacement S equal to ut plus half at square. So because it is coming from here to ground, so displacement is 20 downside. So if you take up as positive and down as negative, so minus 20. And this is because initially it has all velocity in x direction only, horizontally only. So there was no initial velocity in y direction. So u will be 0 because we are considering only vertical motion only in vertical direction. Plus half into acceleration is minus g into t square. Minus minus plus 2, 5 and 4. So t is 2 seconds. So total 2 seconds it will take. So t equal to 2 seconds. So in 2 seconds, the ball will fall from this side to ground, right? But now you can see that in 2 seconds, how much would be the horizontal displacement? Suppose the wall was not here, then how much, what could be the value of this horizontal displacement? That is x. Suppose x is how much? Initial velocity is always constant, 6 into total time. So that is 12 meter. If wall was not here, this could have been 12 meter, right? Now, so this is 4. Let me draw the diagram again. Initially, it had like initial velocity only, and if there was no wall, it could have followed this path like this. So total is 12. So this is 4, and this is 8. Now, but you can see that this wall is here, so it will strike and it will come back again. It will come back with the same speed and at the same angle with the horizontal at which it right. So this will come, it will hit at the on the wall and it will come back with the same spin at the same angle with the horizontal. And now again, you can see that. See, I told you that it will follow the same path, right? Same path. So it will come like this. Same, exactly mirror image of this path. So this path and this path will be a mirror image to each other along. Suppose this is your mirror. So this would be the mirror image of this. So if this wall was not here, so this would have gone this way, and this complete thing was from here to here 8, from here to here 8, because this is 8, but this is already 4. So this is 4, but this wall is here. So it will not go beyond this wall. So it will again come back after striking the wall. Again, it will rebound with the same speed at which it will hit the wall at the same angle. So now, whatever path it will follow, that will be the mirror image of this path, right? That will be the mirror image of this path. So this is 4. So again, it will follow and strike over here because this is also 4. Now, so this will follow this path. And again, because all collisions are elastic, so after striking here, it will again go back. So it will follow the same path, and like this, it will go, and it will again come out of the trains from the same point where it started its journey. So from here only, it will come back. So it is asking that how much time it will take, right? So in 2 seconds, it will come down from here to here, here to here, here to here, and in the all collisions are elastic. So in the same 2 seconds, it will go up as well. So total time it will take 4 seconds during the entire journey. Understood or not? Or do you want me to explain again?
Yes, sir. Understood.
Sir, I
Are you
didn't
seeing?
understand the time part. And sir, one more thing. Sir, how do we know that it will strike the A wall only once?
No, because in the beginning only we calculated the time and we also calculated the length. How much? Suppose if this wall was not here, if this suppose this wall is not here, so it will not strike to any wall, and it will follow this complete path, then what could be this horizontal displacement? That is horizontal velocity into time. So total 12, right? And this length is already 4. So if wall was not here, it would have gone, it would have traveled this 8 meter displacement along x-axis, right? But because of this wall, it will strike it and it will come back. And the path that it will follow after striking, that path is in reality is mirror image of this path. So this path will be mirror image of this path. So if it is 8 meter from here, so this length will also be 8 meter from here, but it is already 4. So suppose if this wall was not here, it would have gone 4 meter further, but this wall is here. So actually it wanted to go 4 meter further, but this because of this wall, it will again hit and come back. So again, whatever path it will follow, that will be the mirror image of this path. So this is 4. So also, so again, this will be the 4, and it will come and strike at the corner of the trench. And because this is completely elastic collision, so it will come. It will like rebound at the same angle at which it will hit the ground or wall. So angles are always same. That's why it will follow the same path.
Okay, sir. Got it.
So when the ball strikes the corner, it has already covered 8 meters. Then how it will follow the same path? That I'm not
Because the
understood.
path that will the path that it will follow will be the mirror image of this path.
Okay, okay, okay. Got it, got it.
Done, sir.
Last question. This is the question. I will draw the diagram. Diagram is like this is the ground. This is one tower. This is another tower. This is tower A. This is tower B. Height of this tower is 15 meter and height of this tower is 18.75 meter. This is 15 meter, 15. This is suppose C. A, B, C, D. Now solve this.